Paper 9702, October-November 2025, Question Paper 21. Question 1. Rocket motion and energy. Part A. Define acceleration. Acceleration is the rate of change of velocity with time. Part B uses a velocity time graph. The gradient gives acceleration, the area under the graph gives displacement. Part B. Part 1. Gradient equals change in velocity over change in time. 320 divided by 20 gives 16 meters per second squared. Part B. Part 2. The area is a triangle, half times 20 times 320. That is 3,200 meters, or 3.2 kilometers. On a velocity time graph, gradient is acceleration and area is distance traveled. Part C. The rocket mass is 2.9 times 10 to the 6 kilograms, height 3,200 meters, speed 320 meters per second. Part C. Part 1. Gain in gravitational potential energy is mgh, about 9.1 times 10 to the 10 joules. Part C. Part 2. Gain in kinetic energy is half mv squared, about 1.5 times 10 to the 11 joules. Part C. Part 3. Average power is total energy gained divided by time, about 1.2 times 10 to the 10 watts. Power needs the total energy gained, both potential and kinetic, divided by time. Paper 9702, October-November 2025, Question Paper 21. Question 2. Pressure, upthrust, and viscosity. Part A. Pressure is force per unit area, normal to the surface. Upthrust appears because pressure increases with depth, so the upward push on the bottom face exceeds the downward push on the top. Part B. Part 1. Three forces act on the falling ball. Weight W equals mg, acting downward. Upthrust U acts upward. Drag D equals 6 pi eta rv. The ball falls, so drag acts upward. Drag always opposes motion. Part B. Part 2. From D equals 6 pi eta rv, the base units of eta are kilogram per meter per second. Part C. Fluid density 920, eta 4.7, mass 2.4 times 10 to the minus 3 kilograms, radius 4.2 millimeters. Part C. Part 1. Upthrust U equals rho gv, with V equal to 4/3 pi r cubed. About 2.8 times 10 to the minus 3 newtons. Part C. Part 2. At terminal speed, weight equals upthrust plus drag. Speed is about 0.056 meters per second. At terminal speed the forces balance, so there is no acceleration. Paper 9702, October-November 2025, Question Paper 21. Question 3. Young modulus and the wire spring. Young modulus is tensile stress divided by tensile strain, within the limit of proportionality. The wire resistance is on naught equals rho L over A. Part B. Part 2. From E equals stress over strain, rearranged to F equals EA over L times X. So the spring constant K naught equals EA over L. Part C. Stretching the wire makes it longer, so resistance rises in a straight line. The spring constant stays at K naught, a horizontal line on the K versus F graph. Part D. Copper wire, resistivity 1.8 times 10 to the minus 8, young modulus 1.3 times 10 to the 11, diameter 1.6 millimeters, resistance 0.034 ohms. Part D. Part 1. Area is pi d squared over 4. Length L equals RA over rho, about 3.8 meters. Part D. Part 2. Spring constant K equals EA over L, about 6.9 times 10 to the 4 newtons per meter. Use the same cross-sectional area A in both R equals rho L over A and K equals EA over L. Paper 9702, October-November 2025, Question Paper 21. Question 4. Diffraction, grating and polarisation. Part A. Diffraction is the spreading of a wave as it passes through a gap, or around an edge or obstacle. Picture water waves opening out after a narrow harbor mouth. Part B. Wavelength 540 nanometers, slit spacing 5.0 times 10 to the minus 6 meters. Each slit diffracts the wave. Bright orders appear on the screen. Central order n equals 0. First order at 6.2 degrees. From the grating equation, d sine theta equals lambda. Second order at 12.5 degrees. Here d sine theta equals 2 lambda. Bigger n gives a bigger angle, higher orders are dimmer. Each bright fringe obeys d sine theta equals n lambda. Rearrange to sine theta equals n lambda over d. Part B. Part 1. First order, n equals 1. Sine theta equals 0.108, so theta 1 equals 6.2 degrees. Part B. Part 2. Second order, n equals 2. Sine theta equals 0.216, so theta 2 equals 12.5 degrees. 540 nanometers is 540 times 10 to the minus 9 meters. Always convert nanometers to meters before dividing. Part B. Part 3. Bright fringes at 0, plus or minus 6.2 and plus or minus 12.5 degrees. Higher orders are dimmer. Part C. A polariser at 45 degrees obeys Malus's law, I equals I naught cosine squared 45, which is half I naught. Every fringe is halved, the angles stay the same. Paper 9702, October-November 2025, Question Paper 21. Question 5. Kirchhoff and the Thermistor circuit. Part A. State Kirchhoff's first law. The sum of currents into a junction equals the sum of currents out. It is just conservation of charge, what flows in flows out. Here is the circuit, a cell with internal resistance R, in series with the parallel combination of resistor R and thermistor T. Conventional current leaves the positive terminal, flows through R, down the right rail, and returns on the left rail to the negative terminal. At the junction the current splits into IR through the fixed resistor and IT through the thermistor. By Kirchhoff's first law, I cell equals IR plus IT. Part B. Part 1. An NTC thermistor has resistance that falls as temperature rises. Part B. Part 2. Why does the current in R fall? Temperature rises, so thermistor resistance falls. The parallel combination R parallel T has lower resistance, so cell current rises. Lost volts IR across the internal resistance increase, so the potential difference across R falls, and the current in R falls. Part C. E equals 1.5 volts, R equals 0.12 ohms, R equals 6 ohms, and IR equals 0.2 amps. VR equals IR times R, 1.2 volts. For the cell current, E equals I cell R plus VR, so I cell equals 1.5 minus 1.2, divided by 0.12, which is 2.5 amps. The thermistor current is 2.5 minus 0.2, 2.3 amps. RT equals 1.2 divided by 2.3, about 0.52 ohms. The voltage across R equals the voltage across T because they are in parallel. Paper 9702, October-November 2025, Question Paper 21. Question 6. Tritium, structure, decay, and quarks. Part A. Part 1. In a neutral tritium atom, 1 proton, because Z equals 1, 2 neutrons, because A minus Z is 3 minus 1, and 1 electron. Part A. Part 2. Tritium has 1 proton and 2 neutrons in the nucleus, with 1 electron orbiting around it. Part B. Part 1. In beta minus decay, tritium becomes helium-3, plus a beta particle and an electron antineutrino. Check nucleon numbers, 3 equals 3 plus 0 plus 0. Check proton numbers, 1 equals 2 plus minus 1 plus 0. Part B. Part 2. X is the electron antineutrino. Balance the top numbers and the bottom numbers separately. Part C. The tritium nucleus is 1 proton plus 2 neutrons. A proton is up down, a neutron is up down. That gives 4 up quarks and 5 down quarks in total. Count U and D across all 3 nucleons, 2 plus 1 up, and 1 plus 2 down.